I was asked if I had what my title was. I just say developer. I think we attempted to have like fancy titles and stuff, being a startup, but we were getting really confused because the titles kept changing and sort of felt almost like Prince or something. So most of us are just developers in the team, and I am fortunate to be a part of a startup construct. And it's a team that consists only of developers, more or less. And of course, that's a good thing, but the problem is also there's not really anybody restraining us in terms of what we want to do and when we want to use more resources. And it's been a very interesting story how we've made the move to the cloud from an on-premise system. And I'd like to share that story with you. And it's not all roses. It's an interesting story, and I hope you will appreciate it. But just a quick introduction about me, because I haven't really. This is my first. It's my first DevOps conference I've actually been to. I mostly speak at mostly .NET and some JavaScript developer conferences. So this is my first time in this group, standing up here anyway. So just a quick introduction about me. I'm, there we go. I'm a backend developer, Pluralsight author, C# MVP, and they keep changing the title, and it's something Visual Studio Tools something now. And I've also written for O'Reilly and a bunch of other stuff. And I guess this stuff is supposed to give the impression that I'm an expert. And I like to think that I'm pretty good at what I'm doing. I mean, I'm not horrible at DevOps. I'm pretty good. So there's a lot of talking about cloud maturities. I guess it's the new fancy way of modeling and figuring out where a company is at in terms of delivering their services or their system in the cloud. And I vision it's almost like an egg ready to get hatched, and this beautiful bird's going to come out flying. And ideally, if you're mature for the cloud, you have the best team, and we do. We have some of the best WinOps devs that you can find. They're pretty good. We've done this quite a few times. It's not the first startup. We actually had at least handfuls of startups that we've made, and they've grown big, large, beyond our imagination, doing pretty good. And that's what I dreamt last night. Turns out, actually, we are everything except from that. We are a bunch of developers who had an on-premise system that we decided should go to the cloud, and none of us knew what to do. And it's been quite a struggle, because usually when people talk about this sort of operations, they paint these perfect pictures of these beautiful processes and pipelines and how it's going to turn out, and how you have all the resources in the world in terms of both people and money. And it's just going to turn out absolutely perfect. I'm going to show you some of the challenges that we had and the solutions that we ended up with. And although they might not be perfect, I do think that we came a good way. So if you don't mind, I'm actually going to sketch this out, because there was no way I could put everything on a PowerPoint without making it absolutely confusing. So I'm going to just go out of PowerPoint here and switch over. I'm not sure why this one is sort of like on and off the microphone. Hello? Is it better like this? All right, I moved my head around too much. And the screen, let's see if we can get this back on now. Okay, all right. Sorry about that. This is Surface, the first generation. I absolutely love it, but it is also a pain in the ass. And keep in mind, this is 4 gigabytes of memory I'm struggling with here. So just a short rundown of the system and what it does. It's basically a very flexible enterprise financial planning system. Usually you'll do things such as forecasting, budgeting, and planning processes, and anything that has anything to do with financial planning. And more or less, all this stuff users do in Excel, but you really shouldn't do, and you have more than one users. So that's what the system does. And I'm not going to spend too much time talking about what it actually does in details and so on, because that's not really the purpose of the presentation. But I'm happy to give more details and do some advertising for it later if you want to. Now, let's go straight ahead and just talk about some of the challenges we had. And I'm just going to draw out, basically the team consists of, and I probably should use black for this. The team consists of Johan, this is the project manager, scrum master, product owner, and backend developer. We do a lot of things. We have Matthias, he's one of the front-end guys, a very cheerful, happy guy. The youngest of the bunch, but probably the most mature of us all. We have Thomas, the really smooth front-end guy. He does the front-end compared to Matthias, who does the back-end in the front-end. Yeah, there's an important distinction there, apparently. Then we get, I guess, the main product owner, Anders, sort of a crazy person. He's not that short, sorry. He's the crazy person giving us last-minute ideas or things that we need to do, such as, oh, by the way, the multi-tenancy system, we need to support different versions running side by side. You can do that, right? At least 2. So he's the one coming in with ideas, and he's also helping out with some of the scripts for the database, because he's quite good at that. Then there is me. I'm a back-end slash, I don't know, the cloud architect sounds really big. It sounds like I'm architecting the cloud. Basically, I'm attempting at moving the system to the cloud from on-prem, and that's my main responsibility, and the back-end development that is required with that, such as the routing library and so on. And then we have a UAT tester, domain-specific, Alex. He's there only half-time. And that's the group of people. In the very beginning, it started basically with Anders, who had an idea, and his idea was to create this system. And he had a conversation with Johan, and Johan said, oh, yeah, I can do that. So Johan sat down and sat there for a day and night and coded up this beautiful system that was going to be just, an MVP, a prototype. And this system consisted of 6 services, everything from aggregation engines to calculation engines and several things that we needed. And of course, as with all microservices, they were just beautifully separated and had no dependencies on each other whatsoever. And there was no chance in hell there was like this bottleneck pipeline to a little SQL server down there that had to manage anything, and there was absolutely no performance issues whatsoever with nested loops and beautiful things like that. All right, so that's how the system looked like, and I guess it makes us feel better with calling it microservices, although it's basically SOA, which means it's something vaguely abstract that's supposed to be separated into small pieces, but it's not really. And that's when I joined the team. When I joined the team, they had refactored out parts of the system and made it a little bit better, but there's still some interdependency, and the team had grown to being 4 of them instead of just 2. And I joined the team, and I had to move this to the cloud. And when you do such a thing, you have to ask yourself quite a few questions, and we had a lot of discussions around this. And I'm going to go through the questions that we had and that we had to answer. And I'll make sure to make these drawings available later if people are interested. First of all, we had to decide on which cloud provider to use. It's actually a really important thing to do because it's going to decide a lot of the possibilities you have in the future and also the costs associated. None of us really knew how to calculate the cost, and if you're going to move to multi-tenancy solution, it makes it quite challenging because basically you have to predict the usage the users are going to have, or the tenants, and how you can be cost efficient, and it's when you're just preparing to scale but you're not yet scaling, that's hard. So we had to decide on the cloud provider. We had to decide on the multi-tenancy model, because there are many different types of models. If these symbolize different type of tenants, we decided on having one client, one front end, I guess you can say, that could be one or several instances. And then we would have all our services, which individually should be able to scale out both vertically and horizontally. And then afterwards, we had to decide on how we're going to manage data storage. And there are a lot of questions in regards to data storage. First of all, Do you want all the users to use, are you going to put everything in the same table? Are you going to put things in different tables? Are you going to put things in different databases? Well, we ended up on making sure that each tenant had their own database, one or several. First of all, we don't really need to start thinking about them having quite several databases. We know how much data we're talking about in the beginning, but we also have to make sure that we can actually scale out and we can allow each tenant to have several databases. This is probably the most secure model, but it's also one that requires a lot of management, and it also requires a lot of new restructuring for us. On the data storage, we had to also decide on how we're going to manage security, because aside having access, obviously, to data to the tenants, once we decide which tenant to go towards, we need to think about how did we make that decision. Obviously, you're going to have some sort of mapping somewhere where you have all the information of all the tenants and how you're going to connect to them. And that means you're going to have this one point of failure. If somebody gets access, shit's going to go down. So how are we going to manage security? Besides security, we had to talk about storage elasticity. Working with SQL Server, we had to basically make a decision if are we going to over-provision or under-provision? Or do we actually want to allow the databases to scale? Do we want to use elastic databases? And we had to look into that and decide if that was something that's going to be cost efficient for us at such an early point. The next question would be if we're going to need cache and queues. Usually you go like, oh yeah, you always need a cache. But we weren't sure if we needed it quite yet, and I'm going to talk about that a little bit later. In terms of the multi-tenancy model and how we manage the services, we had to think about horizontal as well as vertical scaling and how we're going to manage that, how we're going to manage our scale sets. Afterwards, we had to think about automation and our pipelines and processes and how we're going to manage the costs associated with them. And also, in terms of talking about costs, to be able to provide a good service level agreement, we had to meet the service level agreement that Azure provided for us because we had decided on going with Azure. We had separate quirks we needed to manage, such as using something called Hangfire, which is something that basically just kicks off works in its own processes, and also managing SignalR, which is a WebSockets communication framework, I guess you can call it. After all those things, there's still the integration and deployment pipeline to the different environments. Where are we going to do our testing? How are we going to manage performance testing, monitoring, profiling? What is our branching strategy? And how are we going to manage traffic and load balancing and multivariate testing? So one by one, I'm going to talk about how we ended up doing this. With the cloud provider, we decided on going with Azure. The reason we went with Azure was we were already doing all .NET development, and I'm quite familiar with the services and platforms that Azure provides, and we felt that we had already a good introduction there, and we could get started much faster. With the multi-tenancy model, we decided that we're going to have separate tenants, and each tenant is going to be recognized by the subdomain they're going to use, added on to our domain. And there's going to be one front end which can scale to several, and the same thing is going to apply to the services, and each tenant is going to have one or more databases. Now, the client, we had to make the decision if we wanted, do we want to have our own virtual machine, which we want to manage completely fully, which means a lot of manual work and also managing updates and everything else, or do we want to chuck it into one of our cloud as a cloud service, as a web role, or do we simply want to keep it as a web app on Azure? Now, it's only JavaScript and HTML. We might as well just statically just serve them up on a CDN if we wanted to. But we decided on having it as a web app instead, and we have the scaling that we need, which can be automated, and that would simplify things for us. So that means that we made a decision that the client is going to be hosted a bit separate from the rest of the services, because we already had a clear distinction between the services and the client itself. In terms of how we manage storage, we decided quite quickly on going with SQL because that's what the on-premise had. But that means we had to use Azure SQL. Azure SQL is not quite like SQL. It has its own little quirks. One of the things is it doesn't support events, which made it a little bit tricky when we wanted to scale out our SignalR service, because some of the backplanes provided for SignalR for scaling out is for SQL, but only for SQL and not Azure SQL. I can talk more about that challenge a little bit later. So we decided on Azure SQL. There was no point on moving to different type of storage, but we needed to have a secondary storage because we had been using file access locally on the servers where the system was installed. And to not have to change too much, we decided on going with Azure File Service, which basically just allows you to set up a virtual mapping, and it was an easy transition, which has turned out to actually create a lot of problems for us because it hasn't been going so smoothly, and we keep losing the mapping, which means that suddenly the users can't access their configuration files, which is what we're hosting there on the file service. So actually that turned out not to be the best of decisions that we made, and we'll have to change that and move over to table storage instead. We had to decide on the routing model, and we went with the subdomain. With the subdomain, when you have web apps, it does support wildcard subdomains. So that's what we went for. And we decided that the flow was going to be that when a tenant comes to the site, we grab up the subdomain, we check if, do they exist, do they have a database, is the database online, and does the user exist in that database with those credentials? If it does, we're going to give you a token, and that token is going to travel with you and provide us the information for each request that you give us. And actually, I could show you a much better picture of the full solution and how it ended up by going back to PowerPoint, and hopefully it's not going to mess this up too much. Let's see now. Well, I mean, it's just started in the wrong place. So that's how the system looked like. I'm not going to draw all of that because that's going to take some time. So that's the flow of the system. So all the different buildings, they represent different tenants. And I don't know why this keeps... I'm going to stop using this one because it doesn't seem to be doing what I want. Come on. Okay, there we go. I'm not going to touch anything. So each building is a tenant, and they type in the address, we grab out the subdomain, and we check if the tenant exists, and also if the user exists with those credentials. This is done towards our authentication service. The authentication service goes towards a separate server where we have all the information, we have all the different mappings. Everything is encrypted. It's always encrypted. We're using the always encrypted feature in SQL 2016. And for the encryption, in terms of the key and the secrets, we're going to use Azure Key Vault. We haven't quite added that yet, but we're going to add that. Basically, we're going to allow some of the customers who really don't want us to see their data, they're going to have the option of actually being responsible for the key, and we're not going to be able to even access the key. This is also going to be really important as our team grows larger, and we don't want everybody to have access to absolutely everything. It's going to make it much easier for us to actually work on the different databases without seeing data which we shouldn't have access to. So after authentication, a token is sent back, and this token lives for X amount of time and travels with you as you make different requests. On each request, we are setting the data context for that request. The services have no idea if it's on-prem or multi-tenancy. They really don't know, and they don't care. Because once you make a call to any of the services, and they're also mapping toward between each other. Once you make a call, it will go and have a look at the token and know exactly where to go. I'm not going to explain the exact details of that, because I'd like to keep that a secret. But basically, the data context is not set before a request is made, and the context is gone as soon as that request is gone as well. All the different services that we have, inclusive the web app, which is outside of our cloud service, which is a way to configure up microservices on Azure. Each of them are at least 2 instances to meet the SLA agreement, and they can scale up as much as we want. We decided on going with cloud services because when we were setting this up, Service Fabric didn't quite seem ready, and quite frankly, we weren't really sure if that would be a good choice for us. And that I will come back to at the end of this session and talk about what's happening now with Service Fabric. So we have all these different services in several instances, and then we have Azure File Storage, which we are using, and we're going to move over to table storage. We have a separate portal where we can configure things, and we have our dashboards for stats and health and also cost. One really cool thing with Azure Key Vault is that you have almost real-time logging of the key usage, which makes it really easy to see if there's some unusual behavior, and we can revoke the key and set out a new key, and then everything can just continue going smoothly, and we can quite quickly manage whatever the problem was. So that is a very good thing. This is a simplification of how the system looks like right now and how it put it up. But that was only one part of it. So we moved it to the cloud, and that's how it ended up looking. And that was just one part. Being a very new product, and also being a very new team, we had, and please do not judge us, we did not have a build server or anything like that. We've gotten as far as using GitHub and Git and using GitHub's issues and Waffle, and that's how far we've gotten in the process of having anything slightly agile or slightly towards continuous integration. So we had to even set up our continuous integration as well as deployment pipeline from scratch at the same time as we were moving to the cloud. To keep things quite simple, we decided that, of course, we have all the different developers. All the developers, and this is, quite common model, are going to go ahead and push to a GitHub repository. We then have a build server running TeamCity, which I reckon is the best continuous integration service right now to use. It's going to listen for changes. Once they come in, it's going to go ahead and it's going to build, run tests, and package up our services as NuGet packages, and we're just cheekily using TeamCity to host our NuGet packages for now. And once we have those packages, then we have Octopus deploy, which is going to then push out the packages to the various environments that we have. And the different environments that we have, the first one is actually still on the same build server where we run our integration tests. We don't run our integration tests as a part of the TeamCity build, and this is a bit embarrassing, but the reason why we don't do that is because they're really slow. At the moment, our integration tests take a lot of time, so we do actually run them after we have packaged up, and if something is faulty, we have to rerun the packaging. But we do need to run the integration tests on a separate server, because otherwise it's just going to pull down absolutely everything. So we're running our integration tests there, and if we have to, we will go ahead and repackage and restart the process. Afterwards, we have our UAT environment, and the UAT environment is also right now our QA environment. So it's both for all sorts of testing. We do everything from domain-specific testing to actually just testing that things still work and that performance is all right. performance testing is really hard with cloud services, and the problem is also that it's extremely costly, and we simply do not have that type of money. And we have a different provider of servers where we run our performance testing, and we can't run those very often because it's going to cost us a lot. And quite frankly, I'm not sure how well we could mimic actual behavior in terms of load. So basically, we use that when we suspect that we're having performance issues, or when we know that we need to have a quite big scale and we're worried about a specific service, and we do the performance testing one service at a time, as it's just too costly and for us to do the performance testing all the services at the same time. When we do the performance testing, we do not use the emulators, the Azure emulators for cloud services, because they only let you scale to a couple of instances per service, if I remember correctly. So we have our QA and we have our UAT, and after there, the next step is going to the different production environments. And our production environments, we have our cloud environment, our multi-tenancy environment, but we also have clients who have installed the solution locally. And this looks like some sort of messed up server, and that's probably about right. So we have those that have installed on-premise, and we have to push out there as well. One of the challenges we had with our system was that we had both a multi-tenancy solution as well as an on-premise solution that had to be able to live side by side. So at all times, we had to test for both scenarios and make sure that we don't break one environment when we're building on the other one. And that's why we chose to make sure that all our services are completely unaware of the fact that they're multi-tenant. They don't know. There's one place in each service where we can figure out whether or not it's going to run in a multi-tenancy environment or not. And basically, we're also using conditional compilation, so there's no way that you can even compile the things required for the multi-tenancy as long as you set up the right configuration. And if it's the wrong configuration, I mean, you're pretty messed up anyway. So that means that in Octopus, of course, we are also for different environments. We are changing some of the variables, some of the things we don't want to have accessible in our configuration files. So there we are changing the different connection strings that we are using in terms of our own service. And we're also changing which environment to go towards, as well as setting whether or not it's going to run in cloud configuration, or if it's going to run on-premise configuration, or it's going to run the testing configuration, where we're loading up a few more logging tools that we need for that. So that's the pipeline. It's I'm not sure if that drawing makes a lot of sense, but that's our current pipeline on how to manage on the integration and deployment side of things. The parts that are automated here are basically, we have automated as far as this part here. This is semi-automated. Right now, it doesn't go automatically to this step because we still want to move our integration tests to run here. But we have the issue of the performance and also some unpredictability in terms of some of the tests we have. They're not all of them are very well written, and we need to redo them. So that part here is automated. The rest we have chosen to have as a manual process because there's so many things that can go wrong. And it's quite important that we know exactly what we are doing and that we don't accidentally trigger off something which is going to have a bad domino effect. Now, the multi-tenancy solution is currently just one version, but now we are working with integrating all the services going through a proxy because we're going to support at least 2 different versions of a release. So we can have tenants, if they want to be on the experimental track, they can be there. And that's where we're going to do a lot of our multivariate or A/B testing. And then there are also the sort of old school types of big enterprise companies who really want to stay put on an older version because they haven't caught up with making changes on their side, and we might have to actually support that as well. Although ideally we wouldn't do that, but we really need the money. And so that's the pipeline. Now, we were quite pleased with our solution until we actually ended up having the cloud services versus service fabric situation. So to explain this, we ended up using Azure Cloud Services, and I mean, it's just a way of configuring up how you want to wire up new web servers and how you want to wire up what they refer to as worker roles and web roles. Basically, web roles is any sort of API sort of service that you have, and worker roles is something that's just going to run on the server and you probably just do some background work. Now, all the services that we have are web roles. And each web role, the quite common configuration is that you have one web role equals one service, which equals one virtual machine. Now, you can dense them down, and you can have several web roles on one virtual machine, and you can configure up for more density. But this is, I guess, the most common configuration and the default configuration, and this is what we decided to do. And basically, you set up your own configuration of the different services that you're going to spin up, but they're all treated as one. And that goes also for updates, unfortunately. And that also means that we have some lag time whenever we want to do some updates. And it also means that we can't as easily fix problems once they're out in production, and we have to be more careful before we actually make that final push. Cloud services is quite a good thing, and we're very happy with it, although we've had challenges such as, for example, you can't provide your own images, and you might not have everything you need. Among some of the things we didn't have was the latest version of the .NET framework. So we actually have to kick off an installation on the servers that are being spun up after an update or when we're scaling out to make sure that we have installed the .NET framework version that we need, as well as doing the mapping for accessing our file services or our file storage. So those are things you need to think about when you use cloud services. Now, in terms of Azure Service Fabric, Azure Service Fabric is just basically the Azure PaaS that used to exist before. I guess it still does exist, but it's just a continuation of the platform as a service. And it's actually what Skype for Business runs, if I remember correctly, as well as Cortana and a few other services. And Service Fabric is pretty cool. From the outside, it might look a little bit like the whole cloud service configuration, but there's a very big difference. And I had to make a list here because there are a few things here I was unfamiliar with. But the Azure Platform as a Service, which is now referred to as Service Fabric, lets you have, okay, so they use the word nodes, so we're going to refer to nodes instead of going for the virtual machines. So you can have high density nodes, and you can really pack things up, sort of like I was talking about in the cloud services, but it gives you way more leeway, which makes it much more resource efficient. For example, we have some services that don't need to scale out just as much, and we could pack them up and have the nodes in the same place. And it also allows you for independent scaling. Right now, if we want to scale, we can't really do that independently, and we have to change our configuration and redeploy and readjust, which gives us some lag and also possible issues at the time that we're doing it, even though it's supposed to be managed. We can have independent updates, and we can provide our own images, and we have better health monitoring. And we also have would have built-in cache and queues, at least a very simple or basic version of it, which means that we wouldn't have to introduce caching services until much later when it comes to the size where we can't just use what Service Fabric has. But it turns out we couldn't use Service Fabric anyway, so we didn't have to feel as bad, because it would mean that we would have to upgrade every single service that we have to ASP Core. And ASP Core is still a release candidate, and even though it's in the second release candidate, which means that they're pretty sure nothing's going to change, there's still that slight possibility, and we can't afford it right now where we are now with the system itself. So it turns out that Service Fabric was not something we could have used anyway, which was good news for us because we were quite worried about how that was going to turn out. So I'm just going to go back to the PowerPoint slides here and see if it's still there. And just waiting for it to pop up here again. All right, yes, back on. So going from on-premise to this took us about 4 months. I was responsible for the majority of it, or I did this, I guess. And I have to say that after thinking a lot about it, we were considering if we had more resources, if we had more time, what would we have done differently? And we couldn't really think of anything. I think it's ended up pretty quite okay. But ideally, you would have somebody who has done this many times before and is an expert and knows exactly the choices you can make and all the decisions you have to go through. But we didn't have that, and we had to basically just take things one step at a time, having a lot of conversations with fellow developers and figuring out this model at the end of the day. So this is our starting point, preparing to scale. And I think it's going to hold up. We're aiming to move to Service Fabric at the end of the year, where we know that we really will benefit from some of the things it provides, which we currently do not have, such as managing queues as well as caching. Hangfire is right now only one instance, and it's not scaled out. And the same thing with SignalR. We came to the conclusion that by the time we need to scale out Hangfire and SignalR, we probably have come to the point where we need to refactor a lot of our services. We're not at our first release. We don't have a clear domain boundaries. Our microservices are probably going to be ripped apart into tiny, smaller services that hopefully are not that dependent on each other. So we didn't spend too much time with Hangfire and SignalR. And SignalR is for basically WebSockets communication, mostly notifications and chat-like services. And Hangfire is for queuing up and kicking off processes for doing heavier calculations on the financial data that we have, because usually we work with quite dimensional data. Hangfire posed the problem with knowing where the data context is, and it's also one of the reasons we didn't scale. Hangfire runs in a completely different context. It doesn't have access to any HTTP context per se, which means that it doesn't really know where a request comes from, and therefore it doesn't know which tenant it is. And that itself means that we probably should have had some sort of message queue to manage it, but we didn't have the time or the resources to set that up, and therefore we let it be just one instance for now. But those two will need to scale if we're going to be able to provide a good service level agreement and make sure that if one instance goes down, we still have something to fall back on. The way cloud services provides is basically, everything is accessed through the same IP address because it's in a virtual IP address, but they're all on separate machines. And the traffic management and the load balancing is done in the background. And these are all automated scale sets which we can configure, but the scaling up and down is managed automatically. Our Azure SQL, we're going to move out to elastic databases on Azure. Unfortunately, it's still quite pricey, so we couldn't afford it right now. That would handle the problem of over-provisioning or under-provisioning. We know sort of how much we need to provide our users, but once we have several tenants and we have too many to handle, we're not going to know how much resources or when those resources are going to be required. And we're going to need some automated scaling and resource management also on the SQL side. So at the end of the year, we're going to see a lot of changes in our model, and I'm quite curious how it's going to turn out. And I'll make sure I provide an update somewhere with this drawing and see if we have to scratch the whole thing and start over. But as it looks now, we finally made it to the cloud. not a single expert, and none of us having ever done this before at this scale. But hey, it works. So to the cloud. Thank you very much.